Hello, fourth graders. Mrs. Belatash here. And today we're going to go back to our beginning discussion about energy. Energy makes things happen. And there has to be an energy source. 98% of all energy on Earth originally comes from the sun. But it goes from the sun to plants to us to being stored in batteries, all different ways. But most of the energy on Earth comes from the sun. Now you might think to yourself, where's that other 2% from? 2% of the energy on Earth comes from the Earth itself, because the Earth is very hot and it's cooling, and that cooling creates volcanoes and earthquakes and black smokers under the ocean. So some energy comes from the Earth itself, but 98% of the energy on Earth comes from the sun. So energy source, the largest one is the sun. But when we looked at a battery in our first experiments, we talked about chemical energy. There are a bunch of chemicals inside the battery which react and create lots of electrons, and those electrons are part of electricity and they make electric circuits work. We're going to turn our attention completely away from things like that, and first we're going to look at energy sources. Before we get started with our experiments, I want us to put some stuff into our science notebook. So get your science notebook. And you're going to get these 3 pages. The one that says Systems and Energy. The one that says Ramp Setup. And I want you to just to have that so later on you remember it. And this one that says Energy Transfer. Those 3 pages need to be in your science notebook. Make sure you date the page. The very first one, Systems and Energy, and make sure you have numbers on those pages. Then go back to the front to the table of contents, and number 7, you should write Systems and Energy. Mine is on page 15, and then Energy Transfer, and mine is on page 17. So make sure that you have your table of contents completed and those things glued in before we get started. So when we looked at systems and energy, there are 3 columns. The first column says system, the second one says energy source, and the third one says evidence of energy transfer. So remember, a system is a series of parts working together, right? We talked about that, I think, in our first or second day in our engineering challenge. The energy source is where the energy is stored, and evidence of energy transfer, I think we're going to see that in just a minute. Okay. On the page that says System and Energy, Systems and Energy, I want you to write candle, hand rubbing, rubber band cup, and flashlight. Please write that in the system area. And now we're going to see what happens with a candle. So I have a birthday candle right here. There it is. There's my match. I'm going to light the candle. Now, the system is the candle, right? A system is a grouping of parts. So there's the wax and the wick, and together those 2 parts, those 2 tools make a system. Now, so now my question is, what is actually burning? What's the energy source? Well, we can kind of tell that by looking at what's disappearing. Something is disappearing. It's being used up. It's the wax. The wick is not really the energy source. As you go along, the wax will drip and go down, and the candle will get smaller and smaller. The wax is the energy source. What is the wax turned into? Fire, right? We see fire, and fire is really what? Heat. I can feel the heat from the candle, and I can see light. So the answer to number 1, candle, the energy source is wax, and the evidence of energy transfer is light and heat. So the next one you guys can join along with me because it's just using your hands. So put your hands together and rub them. And rub them a little faster. Okay, what's happening to your hands? They're getting hot, right? So what's the energy source? Well, it's not just your skin, right? Where's the energy coming from for you to move? From your muscles. So the energy source is your muscles, the muscles that move your body. How do we know, and what was the evidence that we had that showed us that there was energy being transferred from our muscles to our hands? What did we feel? Heat. So the energy source were your muscles, and the evidence of energy transfer is heat. The next one on the list is the cup with the rubber band. And if you guys have a cup and a rubber band, please join along. So I'm going to push down on the rubber band and we see something happening. We see the rubber band, when it goes back and forth very quickly, we say it vibrates, right? We see the rubber band vibrating. And we also can hear something. We hear sound. So, where does the energy come from to make the rubber band move? From my muscles again. So, the energy source is your muscles, and the evidence of energy transfer is motion and sound. The last example that we're going to do together is the flashlight. So I've got my flashlight, and first I'm going to take the batteries out. And I'm going to turn on the flashlight. Do you see any light? No, because the energy does not come from the switch. It doesn't come from the light bulb. It doesn't come from the flashlight. The energy comes from the batteries. So the energy source for the flashlight are the batteries. So you could write batteries. The evidence of energy transfer is light. When we see the light, we know that there was an energy transfer. So when you look at this package, systems and energy, we know the system, the candle, your hands rubbing, the rubber band in the cup, the flashlight. In order for something to happen, you need energy. Remember, energy makes things happen. You need to have a source for that energy. And the wax was the source, our muscles were the source, and the battery was the source. And the evidence that we know that something happened or that there was energy there is because we observed something happen. We observed light and heat. We observed motion and sound. All of those things help us know that energy was present. Okay, so now what we're going to do, boys and girls, is that we're going to do this next experiment, ramp setup. And it says use the procedure to set up 2 ramps. Tape the ramps side by side. You can read all these directions. But basically, I set everything up exactly as they requested in the experiment. And now we're going to find out how the energy source, which is my muscles, and the pull of gravity, how that affects the motion of some balls rolling down a ramp. Here are the 2 balls. They're exactly the same size. I have 2 ramps exactly the same. And they're going to be running into this bin, which is the same distance. So all of these things are the same. The only thing that's going to be different is how far up the ramp I place the balls. So I'm going to put 1 ball at 2 and 1 ball at 5 and go. So the ball that went up higher went faster and farther. Well, I don't know farther, but it went faster. Okay, here we go. 1 at 2 and 5, go. Definitely went faster if it starts at 5. Here we go. So my takeaway from that experiment is that if you have two balls that are the same mass, the same weight, you have two ramps that are the same, you have the same smooth floor, and you have the same distance, the ball that starts higher up the ramp speeds up and goes faster. I'm wondering if there are some other things that we can test besides the height, how high up the ramp we go. I have different size balls. I have a large steel ball, I have a medium steel ball, and I have a small steel ball. What can we do with that? Well, why don't we test to see if the weight or the mass of the ball makes a difference on how fast the ball goes. The first experiment, we noticed that if you place the ball higher up the ramp, it goes faster. Now I have three different balls. I have a bigger ball, I have a medium one, and I have a very small steel ball. Now let's make a prediction. If we put all of them at the same height, which one will hit the bin first? Let's try. I'm going to first start with the large steel ball and the medium steel ball. They're both going to start at the same place because this time, instead of testing how high up the ramp, we're testing the mass of the ball. So this one is going to start at the top, this one's going to start at the top, and go. They hit at exactly the same time. I'm trying to do it 2 more times. Hit at the same time. 1 more time. Hit at the same time. So I'm going to try again. I'm going to try the large ball and the small ball. Here's the small, here's the large. Hit at the same time. 1 more time. Hit at the same time. Hit at the same time. That is an interesting experiment because we tend to think that things that are heavy fall faster, but they don't. They travel at the same speed as something that has a heavier or lighter mass. The thing that makes the difference is how high up the ramp you go. Now I want to see what happens to the ball when it hits something. So I have put a little cork on the runway and we're going to see what happens. So I'm going to take the ball, I'm going to put it at number 6, and we see what happened to the ball, to the cork. What I want to do an experiment, and I want to test how far the cork is moved by the ball if we started at 6, 4, and 2, and if we do the large, medium, and small balls. In your notebook, we're going to be filling this paper out together. So I'm going to start with the large steel ball. I'm going to do it at 6, 4, and 2. The medium steel ball, 6, 4, and 2. And the small steel ball, 6, 4, and 2. And then we're going to record the distance that the cork is moved by the ball. I'm going to start with the large steel ball, and I'm going to start it at position 2. Here's the cork, and go. The cork is moved 34 centimeters. Record that data. Now I'm going to start the ball at 4. The cork was moved 56 centimeters. Please record that data. Now I'm starting the ball at 6. The cork was moved 72 centimeters. Please record that data. This time I'm going to use the medium-sized ball. I'm starting it at 2, at the level 2. The cork was moved 18 centimeters. Please record that data. I'm at level 4. The cork was moved 32 centimeters. Please record that data. I'm at level 6. The cork was moved 43 centimeters. Please record that data. Now I'm going to use the small steel ball. I'm starting at 2 centimeters. The cork was moved 7 centimeters. Please record the data. I'm putting it at 4. The cork was moved 13 centimeters. Please record the data. I'm putting it at 6. The cork was moved 17 centimeters. Please record the data. I think this is a really fun experiment. I want to talk a little bit about the energy of the balls. So right now, when the ball is just sitting on the floor like that, it doesn't really have any energy, right? There's just some matter sitting on the floor. But when I pick up this ball, what happens is that I'm giving it some energy from my muscles, right? I'm picking it up off of the floor, and gravity wants to pull it down, right? But so it has the energy of position. It has potential to fall and to do something, to do some work. So the higher I put the ball, the more potential energy it has. So when I put the ball at the top of the ramp, it has potential energy. When I let go of the ball and the ball starts to move, it has kinetic energy. When we put the cork on the ramp, we introduced a new force. Something was making the ball and the cork stop, right? I'm going to take the ball, I'm going to let the ball roll down, but the cork stops before it gets to the end of the ramp. If the cork wasn't there, the ball would hit the end of the bin at the end of the ramp. What is making the cork slow down and stop? Well, the answer is friction. The ball is pushing on the cork, but the cork is pushing back. The cork is interacting with the surface of the tube, and it is pushing back against the ball. I hope you had a fun time watching all these balls roll down ramps and collide with each other. I had a lot of fun. Remember, energy makes things happen. See you next week, guys.